So let's talk about section 5.6, annuities, loans, and repayments. As we work on these sections, guys, do be aware that when you are kind of looking at these, we are doing future values, present values, and then payments itself. So just kind of keep that in mind that there is keywords that we want to really watch out for. Okay, so since we are dealing with annuities and all that different stuff, there's a lot of new formulas out there, and I definitely want to make sure that you are following along with these new formulas. So it's very important to kind of keep these formulas in mind. So this one here is for the future value of an ordinary annuity. Now, what you're going to be looking for, again, normally given in the problem itself, it's going to give you a couple of things. Now, as we look at these formulas and different things like that, one of the first things I want to kind of point out to you is be super sure that you're reading everything. Again, are you going to have to memorize this formula? Absolutely not. I don't know many people who actually do. I don't even have the formula memorized. Okay. So don't think like you have to know this one like super, super amazing. So what I would suggest is, again, write this down, but I would also write down this right here as well, and this right here. So like everything on this slide is super important. You may not want to write down like if R dollars, like, okay, just put the formula down and what does each letter mean. S itself is going to represent what we call a future value. R, and it's a big R here, so please be aware that's a really big R. It's for a reoccurring payment. Okay. Now that reoccurring payment can be something that you pay towards a loan, or it could be a reoccurring payment that you get. So R is like some type of reoccurring payment. Little r, so slightly different. This is going to be a rate. And again, it's normally given as a percentage. Okay. T is going to be time. And K is going to be the number of times that are compounded per year. Again, K is normally written as a word in the problem itself. Now, what I also want you to remind yourself of is in the formula itself, you'll notice there's no little r and there's no K written here. So there's an I and there's an N. Okay, so these three things here, they actually have their own formulas. Okay, so this is why I said these are also helpful. So I itself is going to be what we call the interest rate per period, which means R is going to be the interest rate, but K is going to be how many times that interest rate is being charged or used. So that's where per period being K is that how many times I'm compounding per that year. So if there is quarterly compounding, that's going to be 4 periods a year. So what is that interest rate per the period? N itself is literally how many periods there are, like the total of something. So in our case here, if there's 4 periods, and we're doing this for say 2 years, that means that 4 times 2 is going to give me 8. So there's a total of 8 periods in which I can make a payment or be charged an interest rate. Okay, so that's what those are. And so keep those in mind. It's really kind of important to keep that in mind. Again, I would strongly encourage, make sure that you have all of this written down because again, it's very important to see. So let's actually do an example with that. So that way we have an idea of what we're looking at as we work our way through these. Okay. So our first part as we go through this problem is that we're going to look at find the 5-year future value of an ordinary annuity with a contribution of $750 per quarter into an account that pays $10,000 per year compounded quarterly. Okay, so the first thing I started to see was find the future value of a 5-year future value of an ordinary annuity. First of all, they even use the word annuity, but I also saw in here that we are doing something that's compounded quarterly, and there's a $750 payment per quarter, like contribution per quarter. That's a payment per quarter. Again, they may not use the word payment, so that's why I said like it's something that's reoccurring. So the first thing I'm going to do before I even jump into this problem is I'm going to identify what is the reoccurring payment, my rate, my K, my T, my little I, which again is just R over K, and my N, which is KT. I strongly suggest that you kind of identify going this direction with it. Again, a lot of the stuff is going to be found in the problem, okay? And there's going to be a lot of stuff there that's going to help you out, okay? So the first thing I saw as I started to walk in there, 5-year future value. So 5-year, we already know T, okay? That's our 5-year. We also know that we're doing a payment of 750. Again, this is per quarter. We do know our rate is 10%, which again, I'm not going to write as 10%. I'm going to change it to the decimal format there. And then K. Now, K itself, a lot of people overlook K, and that's just because K is normally written in as a word. I would strongly encourage, look for something that says like compounded, and that's going to be kind of your key idea of like what the K value is. So K is normally that word that is written. And it sometimes doesn't have the word compounded in front of it. It could have been something like this where it says you're making your payments quarterly. So, and that's why I said like it's there. It's just not always written with the word compounded. So sometimes it's both, sometimes it's neither. So keep that in mind. So in our case here, quarterly, quarter means there's 4 quarters in a year. And again, it's always like how many times a year. Once you have these items written down, let's go ahead and make our I and N. Now, N, again, there's 4 quarters per year for 5 years, which means I'm going to have 20 different periods or payments to be made. Okay. Now, I is going to be R over K. Now, R itself is going to be 0.10 and K is 4. Now, one thing I will say, I strongly encourage you to kind of take a peek at this one as you're working your way through this, is go ahead and do this division. But when you do this division, if it doesn't come out to be a beautiful, nice, clean number that ends after, say, 3, maybe 4 decimal places, if it has anything more than 4 decimal places, leave it as the crazy looking fraction, okay? You don't want to go too early, okay? So those are the first things. And again, it's not going to, when you actually do this work, please be aware, they're not going to break it down like this. So keep that in mind. I highly recommend break it down like this on your notes. But if you like jump in and try to look at things like through the Help Me Solve It features or tutoring features, a lot of times they just kind of explain like this is what you need to plug into the formula. But I do find it very helpful to lay out everything. And then once you've laid it all out, you're going to put it all into the calculator. Okay. Again, have that formula written down on the side for you, somewhere that you can easily get to it. Again, remind yourself S is the future value. And remember the formula itself is S equals R. And then we have that 1 plus I to the power of N minus 1 all divided by I. So this was a formula, and then this is me plugging everything in. And this is why I say, go find I and N first, so that way you don't have like a lot of really craziness when you plug it in. Okay, let me pull up my calculator so we can actually see how this all looks in the calculator itself. Okay, I'm gonna put the calculator over here on the side a little bit. And so the first thing I'm gonna do is I'm gonna type in that 750. And then I'm gonna say multiply. And again, for those of y'all, I strongly encourage, start with a set of parentheses and then plug in it as that fraction format, okay? So again, in case you really needed to see that one more time, because, you know, some people don't know where I did that. So alpha y equals number 1. Now, if you have a TI-83, it's not going to allow you to write this in this pretty fraction form, but you are going to need to have some serious parentheses, okay? Like I said, I want to go ahead and put this in with that decimal instead of putting it in as that fraction, but you could put a fraction in there, raise it to the 20th power. Make sure you arrow down here. A lot of people make that mistake and then say minus 1. And then again, on that bottom, put that I in there. And again, arrow out. For those of y'all that do not have that ability to put it in the pretty fraction form, you can plug it in, okay? What I strongly encourage is start again with the parentheses, just like I did here, but you're going to need 1 extra set of parentheses. And what that's going to do is that extra set is going to be around the entire top up here. So I'm going to have that 1 plus 0.025, close that. Now, again, this is the top of the fraction up here. So I have to the power of 20 okay? And then I'm going to say minus 1. Now, this set of parentheses is already closed because that's the one that's to the power of 20. This set of parentheses right here, when I actually hit here, that is going to close the entire top part of the fraction. And then that's all being divided by that denominator, okay? And because the denominator is one thing, I don't need to worry about an extra set of parentheses around it. And we are going to get the same answer. Now, again, we are dealing with money, so I do want to kind of round to 2 decimal places, okay? So the future value of this investment, so if I put $750 away every single quarter, and the account is making 10% per year, by the time I put all the money away, I'm going to have $19,159.49. Now, please be aware that that's how much I put into the account at the end of the investment. That's the future value of the investment. That is not how much money I actually put away. Remind yourself, we're doing 20 payments. So we're putting $750 for 20 payments. Realistically, I'm only putting $15,000 into that account. But because it's earning interest, I'm actually going to earn a little bit of interest there. So we have that $19,158.49 minus how much I actually plugged in myself without any interest. So really, I'm actually earning $4,158.49 in interest. This is why when you talk to somebody about investing, this is what they're talking about, that you really need to kind of pay attention to how much money that you're investing in something. Okay, so let's try this again. And again, still looking for that future value. Okay, so Harry deposits $200 at the end of each month into an account that pays 12% interest per year, and it's going to be compounded monthly. Find the future value for every 4-month period for up to 36 months. Now, again, before we jump into anything, we're going to start by identifying what is that reoccurring payment? Well, I'm paying $200. Okay, that's my payment. Okay, my rate is 10%. And again, with anything, we don't like to actually, sorry, not 10%, 12%. Ooh. Let me erase that. So it's 12%. Okay, and it's being compounded monthly. So understand that K is 12 there. And time is, this is going to kind of vary because we're going to run many of these. Okay, so we're going to look at running quite a few of these. Okay, but what that does tell me is right away for R, we are going to have to take that 12%. And again, we never actually use it in the 12%. We always change it to the decimal and divide by K. And K is, again, it's always a word. And that's where I looked for that word compounded. Compounded really helped me out there. They also, if you really look at it, it says they're putting a $200 at the end of each month. Again, it's kind of giving it away that it's monthly. And double check to see if this does divide out very nicely. And it should divide out super, super nicely here. Okay. Now, in our case here, please be aware that this is going to just be 12 times T, whatever T might be. So in our case here, if we're doing it at the end of the first 4-month period, this will be basically 12 times 4, okay, and 12 times 4 would be basically 48, okay. Now 12 times 4 is 48, but that doesn't make sense, does it? Why does that make sense? Well, let me put this into another term, okay, because this doesn't really make sense. It's not necessarily 4, okay. This is going to vary, but time is always in years. Okay. And when I say a 4-month period, that's 12 times 4. I'm not doing 48 payments within 4 months. No. I'm only making 4 payments, right? So when we talk about things like this here, T is always in years. So when I actually look at that, and again, this is like I said, where people kind of throw themselves off with this one. This is actually going to be 4/12. So for the first 4-month period, I've only made 4 payments. Okay. And again, when I do the next 4-month payment, I'm going to start at 8 times 12. And again, it should be basically 4 months have passed, 8 months have passed. So these are how many payments I've made because I'm making monthly payments. Okay. So once you have that all in there, we can kind of look at that. And again, remember, N is how many payments, like basically you're making a payment at the end of every month. Now I'm going to leave it in this kind of format where it's got a variable here. So I can kind of look at how it's going to look with the calculator itself. Okay. So I'm going to pull out my calculator and I'm going to go into y equals, and I'm actually going to type this in. Let's start with 200. And then multiply. And again, I'm going to start with my parentheses. And then if you've got that ability, remember alpha y equals number 1 lets us put it in that really pretty fraction. Now, I'm not going to actually write it as 1 plus 0.01 because I already know what 1 plus 0.01 is. It adds to be that. It's really helpful if I can do that just to make it a little bit easier. I'm going to put an X in there and then minus 1. And then that's all over there. That. Okay, it's all in there, very nice and neat. And again, for those of y'all that have the TI-83, please be aware, the TI-83, you have to be super, super cautious with your set of parentheses. Okay, you need literally a set of parentheses for that entire top part. And then you have to basically put the bottom in there and then close out the parentheses. Now the top part up here, I can drop the extra set around the 1.01, and that's only because it's one big item to the power of x, but I have the whole parentheses around the top and then the whole parentheses around the whole fraction, okay? And then I can, again, remember we were talking about doing this for basically every 4-month period, right? So I'm going to go straight to my table, not my graph, but my table. And if I've made 1 payment, that means I put $200 down. When I put 2 payments, so I've now put $400 down, but in my bank account, it should say 402 because I'm earning interest every month, right? And so at the end of that 4 months, I should have $812.08. And again, I know there's a Y1 and Y2. Again, there's a reason for that is I'm showing both of the different ways. So for those of y'all, you should only see one when you go to the table. Okay, so you should only see Y1. So I'm gonna literally just go every 4. And so let's see, I have $812.08. I have for my 8th month period. Now be very cautious here if you're using the table like this. You might need to click on the Y value here to actually get the full decimal because it kind of cuts it off. So really it's actually $1,657.13. When I go to the next 4-month period, I've got $2,565.50. And again, just keep going for every 6 months or every 4 months and we can get all that. Okay. So I'm going to take a look at that so you guys can see it here. And here we have kind of literally every single 4 months all the way down to 36 months. Now, again, I do want to kind of point out, and again, this is where things get really, really cool. And I'm going to pull the calculator back up so you can see it here. So again, I've just pulled out all of these. Take a peek at this, okay? So when I'm putting away $200, I'm putting it away for 4 months. I've actually only put $800 into the bank account, but because I'm earning interest every single month, I'm actually going to end up with $812.08. Okay. So if I put $200 away and for 8 months, I've actually plugged in to the bank $1,600. But again, this is how much is actually in the account because I'm earning interest. So not only is my money going up based upon what I put in there, and let's actually kind of look at that. So let's plug in 200 times X because that's how much money I'm putting in. And then this is with it with interest. So when I look at that table, I'm noticing that the longer I keep putting money away, the more money in interest I'm getting versus how much I've actually put in. So when I make it down to 36, I've actually only put in $7,200 over the last 36 months, which would be about 3 years. Okay. But in my bank account, there will be $8,615.40. So I basically, even though I'm putting money away every month, I'm earning money for just letting it sit in this account. And y'all, this is kind of how a retirement fund works. This is basically what we're doing with a retirement is you're putting money away for a rainy day, but you're putting it away and not touching it. Don't touch it. And it's earning interest. And one of the benefits of doing this is even though it's earning interest so that way we have a larger amount in there later on. Okay. So next formula. So this time let's talk about, instead of future value, let's talk about the present value. So with the present value, again, we're kind of keeping that same idea there. If the payment of our dollars is made at the end of end periods, this will be the present value. Now, again, present value and future value are two slightly different things. And a lot of people kind of make that and they don't realize. So again, A is going to be present value. So notice on this formula, we have A. The other formula had S. S was for future value. A is for present. Okay. Everything else is going to be exactly the same as what we had previously. So again, I want to make sure to have this down somewhere with this formula, but I also want to, these are not changing. I and N are not changing with this formula. So this is again going to be the same things as we did on the previous formula. The only thing that changes is A and the formula itself. Okay. So the difference is am I looking for a present or a past? Okay. So like, am I doing future or the present? Okay. Now, it's, like I said, I know this is going to sound a little weird, but I'm going to explain what I mean. So suppose a retiring couple wants to establish an annuity that will pay $1,800 at the end of each month for 15 years. Okay. Now, if the annuity earns 6% compounded monthly, how much must the couple put into the account to establish this annuity? Okay. So they're going to put the money in the account right now. And even though they're putting the money in the account right now, basically they can start withdrawing at the end of the month, $1,800, and they'll basically get $1,800 for 15 years. But how much money do they need to put in the account today to start making these payments to themselves? Okay. So again, the recurring payment here, they told us that our rate is 6%. And again, I'm going to make that adjustment and change it into the decimal. And time is how long do we want to be able to pull that money out for? Again, they told us 15 years. Okay. Now, it's going to be compounded monthly, but again, they're talking about paying for each month. So we know that our K is 12 here. Again, this is what we have to read really closely for. How much must the couple put into the account right now to establish this annuity? Not how much it will be in the future. So if I put this money away now monthly, how much will be in the account at the end of the month? No. I want to know how much money do I need to put in right now so I can start drawing on it and earn this every single month. Okay, so this is why this is going to be our A formula. Now, I and N are still going to be the same thing. So in our case here, I is going to be that 0.06 divided by 12, and our N is going to be basically 12 times 15. Okay. And again, as you guys are doing these, please be very sure that this right here actually divides into a very pretty decimal. Whatever you do, you are not allowed to round. Do not round here. You can only round when you get the final answer. Okay, so I've got all my numbers. So now I'm just going to plug them into my formula. Okay, so as I plug them into the formula, again, it's going to work out that way. Just plugging in, again, the formula itself was A equals our reoccurring payment, and then this big fraction, and it's 1 minus parentheses 1 plus I. Oops, there's I, to the power of n, and that's a negative n. Be very cautious of that all over I itself. It's very similar. Okay, so the future value versus the present value formulas are very similar, but just be very cautious, okay? So what that means, once I plug it all in, again, as I'm just being very cautious of how I plug it into the calculator here, that I need to put $213,306.33 into the account right now. Okay, now be aware. So this is what's really cool. A lot of people don't really see this, and this is where I find like it's super, super awesome when you really think about it. Okay, the couple's basically going to receive $1,800 a month, right? So one of the things to note is even though they're putting money in the account right now, so this is how much money I'm putting in the account right now. Like this is put in. But this is how much they're going to get monthly. So say they did this, say they did this like on January, and starting February, they started getting monthly payments, okay? This is what's super cool to really see, is note that technically the amount of money that they're going to receive over the next 15 years, if I take $1,800 times for 15 years for monthly payments, I am technically receiving $324,000 $324,000 is actually how much I'm receiving. But this is how much I have to put away right now. So I'm giving up this much, but I'm getting this much. Because again, I'm putting the money in the bank account, letting it sit there. It's earning interest. And even though at the end of every month, I'm going to get paid this amount, I'm actually making this amount completely. All right, let's try this again. And again, trying to find those keywords, and let's see if we can find everything that we have. So a couple who wants to purchase a home has $20,000 for a down payment, and they want to make monthly payments of $2,100 a month. Now, if the interest rate for a 15-year mortgage is 6% per year on an unpaid balance, what is the price of the house they can actually buy? So the first thing that we have to talk about is they're wanting to buy a house, right? But even though they're wanting to buy a house, they want to make monthly payments. And they want to make monthly payments of $2,100 a month. But they only want to make a 15-year mortgage. And the 15-year mortgage is going to be 6% per year on the unpaid balance. So what is actually the price of the house that they can pay? Okay. Now, there's a couple of things that we have to be aware of as we're looking at that. The amount of money that they can pay for the house is actually the sum of the down payment plus the present value of what they can afford to pay with all the payments. Okay. So when I look at that, this is going to be basically, we're just going to put aside for now. Okay. This will come in at the end. So realistically, what I'm really paying very, very close attention to is I am looking at, okay, this is how much I can make. And again, it's monthly payments. I'm doing this for 15 years, and this is the rate I got. Okay. And again, I want to buy the house right now. I want to buy the house right now. I don't want to buy the house in the future. I want to buy the house today. So I need to know what that present value is. And that present value is that A formula. Okay. And that's that A equals R times, and then looking for our big fraction. And that's going to be that 1 minus parentheses 1 plus I to the power of a negative n all over I. So again, starting off with the stuff that we need, I need n and I need I. So remember, n is k times t, and I is going to be r over k. Okay, so I'm going to take monthly payments, and again, guys, monthly is the k value. It's always a word. So that's going to be 12 times 15. And then I'm going to take my I, which is going to be R over K. Okay, now that's going to tell me that I'm going to make actually a total of 180 monthly payments of $2,100. I've got my interest rate of 6%, which again, we don't like it as a percentage. We change it to the decimal and then divide by month, which is going to give me 0.005 per month. And again, we're just going to plug that all into our present value formula. Again, present value being A. Now, this is how much I can afford for a loan. This is my loan amount, okay? So this is what the loan will be for. Okay, the present value of the loan. But remember, I had a down payment to put. So when I actually buy the house, this is what my loan is plus my down payment. So this is actually my house price. Now, again, this is the type of stuff that if you go on like Zillow or realtor.com, any of those websites, they have something that does this kind of for you, but this is where it actually comes from. Is you're looking at, okay, if this is the monthly payment I can afford, and this is how much money I can put down, and this is the interest rate as of today, they do all of this math for you because they've got a calculator that somebody built this already. But when you go into a bank, please understand, people with banks, that changes every single day. That interest rate when you purchase a house is changing constantly. It's not the same every single day. So what the interest rates were last year versus this year are slightly different. So this is where we have to kind of run this formula an awful lot depending on the market. Okay, we have another formula. Okay, this amortization formula, also known as the payment formula. Okay, the payment formula looks very similar to the present value formula because it is a present value formula, but solved for payments. So normally in a problem, when we're asking for it, they won't actually give me the payment value. They're going to ask you, they're going to give you the payment value, but you're going to figure out the present value. But there's a couple of times that we're going like, no, I want to know what my payment needs to be. And in that case, this is where this formula comes in, okay? So if I am looking for the payment, make sure you use the one that has big R. Again, all of this stuff, again, write these down, very important. Again, I'm not telling you to have these memorized, write them down somewhere, put them on a one-shot sheet, okay? Have them down so you can easily access them because you're not going to memorize these formulas. I'm going to tell you that. Nobody does. I don't have them memorized. Okay. Okay, so let's take a look at our problems. So a couple that wants to purchase a home with a price of $230,000 has $50,000 for a down payment. Now, if they can get a 25-year mortgage for 9% per year on the unpaid balance, first question is, what will their monthly payments be? What will their equal monthly payments? 2, what is the total amount that they will pay before they actually own the house outright? And 3, how much interest did they actually pay? Okay, so let's point out our key things in the problem that I really want to pay close attention to. Okay. Home price. Home price is this much. Okay, that's very important. Now I'm going to change highlighter colors because I really need you guys to see some slightly different things here. And again, this is kind of where, as we look at these slightly different things, it does make a bit of a difference. Okay, we have $50,000 for a down payment. We're going to do a 25-year mortgage and it's 9%. Okay, now, again, as they told me here, this is monthly payments, right? And again, I said it's not always saying that it's compounded, okay? So what will their equal monthly payments be? So to start us off, this right here is not my loan price. This is my house price, okay? So that's how much I'm actually paying for the house. But I'm putting this money down first, and then I'm getting a loan, right? So when I ask for what is their equal monthly payments, it's not on $230,000. It's actually on something smaller. So we're going to take $230,000 and subtract out 50,000, which means this is basically what I'm actually going to borrow. This is my loan. Again, $230,000 was my house price. So that's what you would see the list price for. But I have a down payment of 50,000. So really I'm only getting a loan for 180. Okay. From there, we're going to take 12 monthly payments times how long that was for, 25 years, which means I'm going to have 300 payments total. It was a 9% interest rate divided by monthly. So this is how much I'm paying per month. Okay. And again, this is my interest rate per month, not what I'm paying. So now we're going to use the formula. And again, I'm asking for what is their payment. So that's the formula that says R equals. Okay. Now remember, it's R equals A parentheses. Now this is where, again, like I said, nobody really has this fully memorized. It's a very ugly looking formula. I divided by 1 minus parentheses 1 plus I to the power of a negative n. Very, very important that we actually figure out all of this stuff and then plug it in. So I itself was this part right here. Remember, this is I. Remember, this right here is n. Now, I am taking 1 plus I, so this is where I'm going to add that together before and plug it in as one big thing, which means if I am taking out a loan for $180,000 with a 9% interest rate for 25 years, I will be making a monthly payment of $1,510.56. Okay, again, this right here is my monthly payment. Now, with my monthly payment, let's continue and talk about this, okay? Because this is my monthly payment, remember, this is how much I took the loan out for. The next question I want to ask is really, how much am I actually paying? So what was actually the total amount that you pay before you actually own the house outright? Now remember, we basically did all this work and this was basically our monthly payment was $1,510.56. Okay. 56. I know it's a little crazy in the way I wrote it. Sorry. This is how much my monthly payment is. But we also had a down payment too. So this is my monthly payment for 25 years, right? So, and we're making 300 payments. So I'm literally just going to go, okay, wait a second. So I have $1,510.56. Again, that's my monthly payment. I'm making 300 payments. So this is how much I'm paying to repay back my loan, plus how much money I put down on the loan. So, and again, I have a typo, so hang on. 300. Y'all, I'm really actually paying $503,000. $503,000 on this house. Oh my goodness. Again, remember, how much did I actually take the loan out for? Maybe that might be interesting. So how much in interest did I actually pay? That's my next question. So remind yourself that we actually paid the loan for all the different payments we had, plus my down payment, okay? This right here tells me the total amount I paid for the house outright. But how much was the house actually worth when we bought it was $230,000. So if I take how much I actually paid, again, this was literally the loan repayment plus the down payment. This here was our actual house price. This is actually how much interest I paid more in interest to buy the house than the house was actually listed as. Okay. Again, I know this is like, it's sometimes if you've never really looked at financial stuff, it's really crazy to really look into this. But this is actually how banks make their money. Okay. This is literally how banks actually make their money completely. Now you could have done it the other way. So there is one other way that you could have done. You could have just done what the loan repayment was without the down payment. If we just go with the loan repayment itself, that was $453,168. Subtract what the actual loan itself was. So this was our loan. And when we do that, again, this was just the loan itself. Okay. And again, we'll get that same answer for our interest. Exact same. Okay. So this is basically the interest paid. So if you only want to do with the loan repayment without the down payment in there, that works too. But our last question, we figured out how much we were completely paying for the house. So I just used the house price, but same idea. So hopefully you guys are learning a little bit about finances. And again, if you have not looked at this before, this is definitely something really fun and unique. And this is probably one of my favorite types of parts in math modeling, is when we really get into these loans and things, because this is stuff that you're actually going to use in the future. If you ever start to look down at houses or even cars, like this is something we look at cars. So some things that you need to watch for in problems is, one, look for keywords. Are we talking about past or future? They may not even say the word future or past. That's kind of where we need to be like, okay, am I actually, like, where am I actually looking? Am I talking about like present, like right now? Are they using past tense, present tense, that type of stuff? Also look for the number of times compounded. It's always a word. Always a word. Be cautious of like the ones that we just did. Again, they don't actually say the word itself. They'll actually say like monthly payments. And so they won't say compounded, but it normally does have the word compounded before it, but it may not always. 3, if you put down a deposit, then you will not be taking that, taking a loan out of it. So that deposit is literally out of what you're asking for. So make sure that you subtract that. If you're looking to buy a house, again, do remind yourself that it's literally going to be the deposit plus what the loan is for. The loan is normally what we are looking at when we're looking at present value or future value, those types of things. Now, remember that the total paid will be always the total amount of payments times the actual number of payments, okay? Plus any type of deposit that you may have had to put down as well. Okay, so keep all those in mind when you're looking at these types of problems. And again, if you have questions, always reach out and ask.